Testing, testing, testing. Hello and welcome to Evan Code Day 3. My name is Harry Moreno. This channel is Domain Expert. Let's jump into it. So, I did look up a little bit about sort of how this. Actually, probably not enough, but basically, this is the calendar, and every row is a challenge. Every row is a day up to the 25th of December, which is Christmas. I don't know. So if you go around and check out previous ones, I think 2016, you just get different art, and I'm not sure if it'll change as you do the challenges. This year around, there doesn't seem to be as much art, but we'll see. Anyway, Advent of Code Day 3. No matter how you slice it, the elves managed to locate the chimney squeeze prototype fabric for Santa's suit, thanks to someone who helpfully wrote its box IDs on the wall of the warehouse in the middle of the night. Unfortunately, anomalies are still affecting them. Nobody can even agree on how to cut the fabric. The whole piece of fabric they're working on is a very large square, at least 1,000 inches on each side. Each elf has made a claim about which area of fabric would be ideal for Santa's suit. All claims have an ID and consist of a single rectangle with edges parallel to the edges of the fabric. Each claim's rectangle is defined as follows: the number of inches between the left edge of the fabric and the left edge of the rectangle, the number of inches between the top edge of the fabric and the top edge of the rectangle, the width of the rectangle in inches, the height of the rectangle in inches. A claim like pound 123 at 32 5 by 4 means that claim ID 123 specifies a rectangle 3 inches from the left, 2 inches from the top edge, 5 inches wide, and 4 inches tall. Visually, it claims the square inches of fabric represented by hash and ignores the square inches of fabric represented by dot in the diagram below. The problem is that many of the claims overlap, causing two or more claims to cover part of the same areas. For example, consider the following claims: 1 at 1, 3, 4 by 4, 2, 3, 1, 4 by 4, 3 at 5, 5, 2 by 2. Visually, these claim the following areas. The 4 square inches marked with an X, are claimed by both 1 and 2. Claim 3, while adjacent to the others, does not overlap either of them. If the elves all proceed with their own plans, none of them will have enough fabric. How many square inches of fabric are within 2 or more claims? To begin, get your puzzle input. Okay. So I didn't actually go and figure out how to read inputs, so maybe I'll figure that out now. So I want to basically paste the input into a file, and I can do that by, I think I can do input.text from pb paste pb copy. Oh, trying to do it the fancy way. Okay. So I try to do it with sort of like command line interface piping, and I don't really know how to do it, so I just opened up Vim and pasted it in that way. And so we have the input here, and that's the input. That's the input. We always managed to locate the chimney squeeze prototype fabric. So we got this giant piece of fabric, 1000 by 1000, and each elf has made a claim about on that piece of fabric. And they all are claiming a rectangle. I guess a square is a type of rectangle. Or rather, these are all squares here. This one's a rectangle, 5 by 4. And yeah, so a square is a special type of rectangle. Okay, and then we have some overlaps. How many square inches of fabric are within 2 or more claims? What does that mean? How many square inches of fabric are within 2 or more claims? Okay, so it's basically asking how much fabric has more than one claim. So in this case, we have 2 square inches. I think we have, because it's 2 by 2. So I think this will be 4 square inches. 1, 2, 3, 4. Are within two or more claims in this example. So here the answer is how many square inches? 4 square inches. And that's 2 by 2 is equal to 4. 4 is the answer. And so we need to figure out what are all the overlaps. Okay. Okay. So how would we read in that file? We could do import OS. OS dot read. Something about open. You open the file. I've been consulting, or I've been looking at this very famous solutions for the 2016 Advent of Code by Peter Norvig, which is I think he's head of AI at Google. He shared some of their utilities for competitive programming, and I'm wondering if there's one for just reading the file. Read. Open. input. So they were using something like this. And then later on they use it like that, input 1. I'm not sure if that was for just for the notebook. Open this day's input file, file name. So I've done it slightly different. I just called it input.txt, and I'm not really formatting that. And then you can try open file name and return that, I guess. And file not found error. Sure. No, I'm not going to use that. And then just do input. And I'm not using the day. So presumably this would open the file. Don't think I need that. The OS module. Dot read. I guess you say input is equal to that dot read. And then just as a sanity check, I want to maybe print out the first 10 lines. URL not defined. I'm not going to make it that robust. I just want to read in the file. Input.txt. Input.txt. It should be a sibling. Oh, maybe it's dependent on where I'm executing that from. So if I were to spin up Python within the same directory, then it finds it. It's interesting. I won't dig into that right now, but I guess that's how it works. And that's the first 10 characters, it looks like. If I wanted to get the first n lines, I could probably split. I think by default it'll split on new lines. And then if I get the first 10 items by line, no. So by default it seems to split on white space. I think that's better. So that's the first 10 inputs by line. Okay. So I read in the thing. I need to figure out the overlapping regions. So I think I want to interpret this stuff like this. And that's the input. And that's that, same thing. Okay, so now the input is line-based. Line-based list. List of strings of lines. And then, so the first part is the ID. It's an ID. And then we have a rectangle that starts at 3, 2. 1, 2, 3, 1, 2. And it's 5 Y and 4 high. So it's always X, Y, X, Y, X, Y. And I guess that's it. So I guess for line and input, I'm gonna make a bit more. I'm gonna make it. Gonna change the name because it helps me think. So these are all claims, and for claim and claims, for each claim, I want to. I'm gonna split on. I'm interested in splitting on the @ symbol, the space symbol, and the colon symbol. And I'm going to start keeping track of some information. Our accumulator, it's generic accumulation, accumulator, and I want to, basically, we have some tokens for each claim, and then for the first token, the first item in the token is going to be the key into the accumulator, and I want to assign it, let's say, just for starters, the first thing there, or the second item, and I just want to really quick yeah, just sanity check on what's being accumulated in there. Token is not defined. Claim. Oh wait, yeah, tokens. This index out of range for 0. Yeah, not sure how the Python split function works. So we had a string like if a is equal to something like this, a dot split. If you just split it, you get that 10a. And if you specify an @ symbol, get 2 tokens. Put in a space, it sort of picked up on the @ and space, but it doesn't split it by character, which is what I wanted. Return the list of the words in string using separator as a delimiting string. So it uses that the entire separator as an argument. Yeah, this is kind of what I want. 1, 2, 3. Oh. Okay, so, but, you know, the first one wasn't bad. We just grab 0, 2, and drop the final character on that. How do you do Python split string many characters? Okay, so you would use a regular expression instead. Or apply Maybe let's do the regular expression. For RE, I want to do RE RE split, regular expression, and the end of the term. Claim. So that would basically be like import RE dot split at space colon A. So I think that's just not a regular expression, that's why. Invalid syntax. So we're using backslash. Just use a string. And it would just be a collection of characters. Okay. Oddly enough, I feel more comfortable doing it this way. Because I think digging into the second element, dropping its last character is not as good. Just my opinion. And so then, I think, so if I also wanted to drop the pound sign, we can get the ID, and then just as a sanity check, I want to also try it where in the first input. So these both differ in their ID length. So the first one has an ID of 1, which is 1 character, and then the second, or this, yeah, the other example has an ID of 10, which is 2 characters. And I just think that's, if we test these two and it's working, then that's probably, it'll probably generalize fine. So tokens, the ID will be the first, or the second item in the list. And then I could probably have a tuple here, where, let's see, 0, 1, 2, 3, 4, 5, 6. I could probably parse it further and have like a 4 tuple. It's actually not a bad idea. Comma next. Right. And then basically we have 0, 1, 2, 3, 4, 5. 5, 6, 7, 8. You can have an 8 tuple. This index out of range, token 0. Let's see, I guess if tokens, then do that. So it might be reaching like the last line or something. Maybe print tokens. Well, I'll tell you what, this first one's odd. Oh, okay, so I didn't add the hash. Okay. And if the length of this split is greater than 1, then try to do stuff. Okay, so yeah, there was some oddness. I think the last line that it reads in must be like an empty line or something. But I'm pretty happy with that. We are using the regular expression. Still, okay. So we've tokenized it, and then we want to figure out the overlaps. So we basically have a dictionary where we have an entry, a key value for every ID. For every claim, the key is the ID, and then we have the dimensions, which are sort of like x offset, y offset, x or width, height. And then we need to figure out where they overlap. Before claiming what is the case we have. And then I guess we want for claim in accumulator. No, we have to calculate the overlap. So it feels like we probably want some sort of like some data structure that is initialized to 0 and none of them are claimed, and then as you process claims you flip fields in that space, and then if you detect that there's a bit that's already been flipped, and make it flip to a second type of bit, and then at the end you can just count all the second type of bits, and that's the number of square inches that have been claimed more than once. So this accumulator should probably be like a doubly nested list. That's the best way I can think of it. Accumulator like this. Do you know how big it is? 1,000 inches on each side. So I need probably a 2D list with 1,000 squared inches. Which I can't really do in my head. Off the top of my head. 1,000 times 1,000. It's a million. I need a million integers. Accumulator is like that. Well, for I in range 1,000, for j in range 1,000. fabric. Fabric is equal to just something like that. And here, fabric 0. I don't know if this is a valid way to initialize this in Python this way, but fabric I is going to equal to this range to I'm wondering if I can initialize, get some sort of list that's length of n, but with the same values repeated. I could do append a 0. So for the first time around, that works, I think. Right, okay, so it's 1,000. So that makes one of them, and then 4, do that 1,000 times. How's it? Inner list is equal to that. We're going to do inner list equal to that. Inner list is equal to that. And then outside of it, fabric.append inner list. And then that should still print 1,000. And the item inside it should also be 1,000. So I think fabric is now a two-dimensional list. A list of lists where the total number of integers in that is 1,000 squared, so 1,000,000. So we have our fabric, and then basically for claiming claims, we're going to do the stuff I'm not going to actually accumulate this way. Length of token. So basically, if we have a claimed, like a well-formatted claim line, I want to sort of flip those bits in fabric. I could probably name these variables. So tokens for is x off or off x is equal to that. Off y is equal to this. Claim width is equal to that. Claim height is equal to this. Okay, so we've got a claim here, and then I need to sort of dig into the fabric and flip those bits. So instead of them being all the numbers 0. They could be 1 or 2 or whatever, anything, just as long as I can tell. Honestly, if we wanted to match the problem more, we could do that. And so now they're all dots. And we could... Right now we only need to keep track of really 3 states. Unclaimed, claimed at least once, or claimed more than once. More than once, aka 2 or more. And so these parameterize a region x, y with height. So if you're given an x, you could probably grab fabric off x, fabric off x, to get just like the first row. You know what? I could use a helper function. So if I had a function where it would be like get so, where I give you the x and y, and it returns fabric value. Actually, I wouldn't really want that right now, but I could probably do that later. What I really want is a setter or claim sum, which basically sets some value to A if claimed once, B if claimed twice or more. And this will operate on fabric as a global variable. I think that would work. If not, I could always just pass it as an argument. So basically, I would need to dig in and say that, you know, fabric x, y has to equal, well, I'll get the current value. The current value is that. And then if cur equals dot, fabric x, y is equal to a. Otherwise, well, I think, yeah, otherwise just set this to b, where b is like the 2 or more. So I got this helper, and now I can drive it somehow using these. And so basically, off x, off y. Basically, for x in range for x in range of x. Well, it's the range is going to be like this. Control or claim width. Oh, but I could probably use some of these starting indexes and stuff. So probably do it. So x for x in range 5. Right? 1, 5. Okay. 3 items. Oh no. I sort of want to indicate like an offset and a width. Start, stop, set. So I could do, I mean, if the offset was 5, and then, whoops, and then I wanted to say 5 plus 3, and do it like that. So for x in range, whoops. We need this offset here. And the width will be, you should range until you do off x plus that. That's the x, and then for y in range. Similarly, off y plus claim height. These are the xy's. I want you to go ahead and claim cell xy. And that should, for every claim, sort of flip the bits, and then when it's flipping bits, the first time it flips a bit, it'll do an A, and subsequent times it'll flip it to a B, and cannot be interpreted as an integer. Ah, these need to be cast, I guess. I wonder if I can do a map. I wonder if that works. No. Maybe tokens is equal to int token or token and tokens. I wonder if that works. Can't do it for empty strings. Anyway, we'll do it like this. Okay. It'd be cool if we could look at that. Okay. Be cool if we could look at the first 10 items. These items are pretty big. I might be able to make it more condensed, but it's probably fine. So we probably claimed items once, and we probably claimed them 2 or more times with the B's. And so to get the answer, we just want to add up the B's. And so I guess I could filter. I would want to filter out all the dots and all the A's and count anything that remains. So for row in fabric, for cell in row. Well, actually, I could probably do some stuff where I index over it. So for I in range million. And then basically I have a row called fabric I, and I want to go ahead and update it with an expression, basically cell for cell in blah. So that's the identity. And if cell equals B. Now I want you to print fabric, and let's see if it's all B's. Let's index out of range. Let's index cell for cell in fabric if cell equals B. X for X in range 10. Yeah, I mean, that should work. And then if X equals 2, that would filter it. X for X in fabric if cell equals B. Zero, 1, 2, 3. Blows up at 3. So 0 went fine. Fabric. Oh, well, actually this should be fabric I. And I don't really need to print that out. And I can extend this to the full range now. Okay, that's all these. And then I want to count them. Early lane. Answer is equal to 0 for row in fabric. Answer plus equal the length of the row. and print the answer. So it looks like we have that many square inches. Okay, 1 gold star. Great. I thought I wasn't going to make it. And if I spend too much time on this, I'm just going to cut it short. I don't want it to be a super long video. Amidst the chaos, you notice that exactly one claim doesn't overlap by even a single square inch of fabric with any other claim. If you can somehow draw attention to it, maybe the elves will be able to make Santa's suit after all. For example, in the claims above, only claim 3 is intact after all claims are made. Okay. What is the idea of the only claim that doesn't overlap? Okay, so then somehow we need to keep track of the claims and whether or not the claim has been overlapped by a new claim. So I guess for every cell we could keep track of, wait, we could keep track for every cell, keep track of the ID of its claimants. But it would probably be easy to keep track for every claim whether or not another claim overlaps it. And then you can just scan over all the claims at the end and see which one hasn't been claimed. I think if we were worried about computational efficiency, it would probably be better to keep track of every claim, like a bag of claims, and then as you detect overlaps, remove claims until you're left with one. And then if the problem guarantees that there will only be one, then you basically only have to go over the claims once. So 2 ways to do it. Either keep track of every cell's claimants, keep track of all the claims and detect whether or not another claim intersects over it. But that second one feels like it could be n squared complexity. I don't know. What do you think? How should I do it? Stream is healthy. It's in HD. If you know it, just scream out the answer. You know how to do it. Let's see. If I absolutely had to do this, if there were a way to sort of, it Probably, I feel like it might be easiest to compute this. So we have the inputs, claim saw. I feel like it might be easiest to just compute this over the inputs, over the claims. So then for claim and claims, basically I want to what is it? It's supposed to be a string. That we split. I want to do something like this, I think, where for every claim we tokenize it. We tokenize it, and how about, so with the A's, presumably it would be a region that would just be full of A's, and that it would be a specific region that corresponds to a claim that was never overlapped. I don't think that helps us much. I feel like you do have to, for every claim, compare it to every other claim and just eliminate them until you get one claim that is not eliminated by any other one, and that's the pristine claim. So for claim and claims, maybe let's generate claim and claims, generate another version of Fabric. I don't know. How about just a dictionary? And then for every claim and claims, we're gonna go ahead and use this ID. And that could be a string. So we're basically gonna go grab tokens 1 and make an entry into D with CID where we do use a tuple like this. Alright, so we got a dictionary representation of the claims data, and they have a key of ID, which is a string, and some offsets and some widths and so I would also like to keep track of a boolean, which corresponds to, I would like this to be like ID of x, of y, width, height, and then overlap. False. And then for claim and claim. Okay, and then we got that. And then do it again. For claim and D. For claim and D. I for J and D. If I key. D is equal to that. D1 is equal to 1, 2, 3, 4. Then X for X and D. Dictionary comprehension. Dictionary comprehension. Well, I think I'm gonna leave this one at 1 star. And I may down the line have a day 3 part 2 where I do actually figure out the overlapping or the pristine claim. After maybe after I sleep on it. It is getting late here. So thank you very much for watching. If you have any requests for other types of videos, please let me know. If you found this interesting, if you like what I'm doing, give me some likes. Consider subscribing. Please subscribe. And that's it for that. I'll see you tomorrow, hopefully, for more Advent of Code 2018. Have a good night.